This is the video for midterm review topics 16 through 22. Number 1, what is the domain of the given relation? You need to know what the word domain means, and it means the set of x values. So now I can look at this set of pairs of points, set of ordered pairs, and just pluck out the x values from each one. So my domain would be 3/4, which is an x value. So 3/4, 3 is the second x value, 0 is the third x value, and 1 is the fourth x value. So the answer to this question is choice A. Number 2 asks, which of the following graphs is a function? And a function has one output for any input. So if we look at choice A, for example, if I look at +2, I will see on the x-axis, I will see that there are actually two outputs for +2. And notice I drew a vertical line. If that vertical line is intersecting the graph more than once, then you know that there is more than one output. This is called the vertical line test. And if that graph is intersecting anywhere, the graph of the vertical line is intersecting the graph of the function or supposed function anywhere more than once, then we do not have a function. Part B might be tricky because you might see, or choice B might be tricky because you can see that we have vertical lines intersecting once. But if I look at the vertical line at +2, there are many, many, many intersection points. So B is not the answer. If I look at C, if I draw vertical lines in, they only intersect the graph once. And so choice C is a function, and that's your answer. Number 3 says, what is the range of the function f of x equals absolute value of x plus 2? Definitely need to see those absolute value bars. A lot of people don't see them when they read, but there they are. They're your absolute value bars. When the domain is -2, -1, 0. So they gave you the domain, and now we have to find the range. So basically, what we're going to do is we're going to take -2 and plug into the function. Wherever we see an x, we'll put a -2. -2 plus 2 is 0. And the absolute value of 0 is 0. So 0 is in the range. F of -1 is absolute value of -1 plus 2, which is equal to, this is equal to absolute value of 1, which is 1. So now 1's in the range. F of 0 is equal to 0, absolute value of 0 plus 2, which is absolute value of 2, which is 2. So this would be my range. Choice A. Number 4. What is the explicit formula for the sequence 2, 6, 10, 14, etc.? If we look, each time we go from term to term, we are adding 4. So this is an arithmetic sequence, and that's a vocabulary word you need to know. So this is an arithmetic sequence. So now we're adding 4 each time. So if you remember, we're going to be doing 4 times the n. That tells you how many times I'm going to add. And here's the dirty part of this, or the part that people forget. I have to backtrack 4 to get like the y-intercept, if you will, which is going to be -2 in this case. So my formula is going to be a of n equals 4n minus 2, which is choice B. Similarly, we have another sequence, 10, 6, 2, -2, etc. If we look, we're subtracting 4 each time. So this is another arithmetic sequence. So I'm going to start off with a of n equals -4n. And I have to this time go back 1, which would be adding 4 to get my y-intercept of 14. And so now I have to look at which choice matches it. And I'm looking for -4n plus 14, which I don't see. But I do see 14 minus 4n, which if I use the commutative property appropriately here, this would be 14 plus -4n, which is the same thing as subtracting 4n from 14. Choice D. Number 6, we want to find the first 5 terms of the arithmetic sequence t of n equals 13 minus 4n. This is my formula. I'm going to plug in 1 to get the first term. So 13 minus 4 times 1 equals 9. 9's my first term. I look at C and D and I cross them out. And then t of 2 is 13 minus 4 times 2, which is 13 minus 8, which is 5. And I look and they both have 5 for my second term, so I can't eliminate. T3 is 13 minus 4 times 3, which is 13 minus 12, which is 1. Both have that. t of 4 equals 13 minus 4 times 4, which is 13 minus 16, which is negative 3. And now I could look and see choice B. You can also see each time we're going down by 4 and do it that way. So you can see that 1 minus 4 is not 5, so A would be out. Number 7, ask what's the domain of the function shown? So here's how I would attack this problem. Domains are my x values, and notice I'm covering up the graph completely. Okay, so here's my graph. I'm covering it up completely. And I'm going to slide my, you can do this with an index card. I'm going to slide my index card from left to right. And I don't know why I can't do it right now. All right, so I'm going to do it with this blue like index card. So I'm going to slide it from left to right, and I'm going to note where the graph starts. And boop, here's my starting point at 0. So I know there's no graph when x is less than 0, and the graph starts when x is equal to 0. And then the graph, as you see, keeps emerging and emerging, and there's an arrow at the end. So I know I could just keep doing this over and over and over again. So my domain is going to be x greater than or equal to 0. All the x values along the graph have to be greater than or equal to 0. There is no graph on the negative in the negative x value region, basically. Okay? All right, so number 8 says, what is the range of the function? Range are my y values. So make sure you know that vocabulary word. Range are the set of y values. And I'm going to reveal the graph. And notice I have arrows. That means the graph really can't ever really be covered up in the negative direction. So this graph continues onward down. So I can get as negative as I want. So there will be no low point. Sometimes I tell kids to look for a low value. There will be no low value. And now we're going to look for a high value. We're going to see where the graph stops. I'll keep going, keep going, keep going, keep going. And boop, at the top here, the graph stops. And it stops at positive 3. So my range is going to be y. All the y's have to be below the high value or equal to the high value. So my y's are less than or equal to 3, which is choice B. Same thing with number 10, except number 10, if I go from low, I don't have a graph. And then at my height of positive 1, at a height of positive 1, remember looking at the y values for the range, my graph starts, and my graph does not stop because of my arrows. So my range is y is greater than or equal to 1. Number 10, domain again. I'm going to look at my x values. I'm going to scroll across. I don't see the graph yet, and boop, here's my first point. It's at x equals negative 4. And then I'm going to scroll and scroll and scroll and scroll and scroll, and boop, I get to a stopping point. I don't have an arrow, so that x value is 5. So my x's have to be between negative 4 and 5, which is choice B. Don't let D fool you. You don't just have a bunch of points along the graph. You have the full line segment. So you're going to get lots of decimals. Like, for example, I can look at f of 2.5, which is not in this list. So this is wrong, and B is correct. Number 11 says state the range of a similar function. Again, I'm going to try this a little differently. I'm going to look for my low y and my high y. Low y is down here at negative 5. High y is up here at positive 3. And again, don't get fooled by choice D here. We don't have just a bunch of points. We have a connected line segment. So you need to include all numbers between negative 5 and 3. State the range. Again, range are my y values. Negative 2 is my lowest. 2 is my highest. I'm between negative 2 and 2. 13 wants the domain of question 12. Now we're looking at x values. I'm looking at my low x value, which is negative 4. Looking at my high x value, which is 4. Choice C. Number 14, looking at the range. Now I just have points. I don't have a connected graph. So I can list them out. So for example, I'm looking at the range, my y values. My y value of this point is 5. My y value of this point is 4. My y value of this point is 2. My y value of this point is negative 1. Don't forget that one. And my y value here is negative 4. So if I listed them out, I would have 5, 4, 2, negative 1, and negative 4. which is choice C. Another range question, which is the range of this function. It's going to create a rectangle to cover this up. What is the range of this function? Range are my y values. So I'm going to go from low to high. And whoops, from low, I see that there's an arrow. So if I would try to list my low, there is no low. Now I have to try to go see my high y value. And my high y value, the graph appears to stop right here. So my high y value is 0. So there is no low value, and the max or the high is 0. So y is less than or equal to 0. Maximum is less than, okay? Number 16, given the relation, if 823675K4, which value of K will result in the relation not being a function? If you look at an ordered pair like this again, the definition of a function is one input has exactly one output. So you cannot have a duplicate input because that would create a different output. So for example, if I had an 8 in for K, then the input 8 would have 2 and 4 as its output. Of course, that's not a choice. But if I try to take, for example, 3, if I put 3 in for K, again, I will have a repeated input, which gives me a repeated output. Or not a repeated output, but a different output. So this, if I was kind of diagramming it, if I had K be 3, 3 would be mapped to 6 and be mapped to 4 in the range. That's not a function. Choice C it is. The others will not produce a repeated X value that would give you another Y value for that same X value. All right, number 17, the current population of a town has 10,000. If the population P increases by 20% each year, which equation could be used to find the population after T years? Very important. When you have a percent increase over time, you have a formula for this. The value in the future equals the initial value. And actually I have this mixed up for a minute. Our usual way of writing this is A of T, so that's the amount of whatever you're dealing with at time T, equals your beginning amount or your principal times 1 plus the rate to the T power. Rate must be written as a decimal. So here we are. Now they called this P equals. So they're not kind of using P in the same way I am, but that's okay. Their P is their amount. So I'm starting with 10,000. That's my initial amount, or my principal, if you will. Then I have 1 plus the population is increasing, so we should be going up. If we're decreasing, this would be a subtraction symbol, but since we're going up, we're going to use a positive, a plus sign, basically, an addition symbol. Now I want to go by 20% each year. 20% needs to be converted to a decimal. So 20%, divide by 100 on your calculator, or move the decimal place over twice. We get 0.2 or 0.20 to the T. And to match it with one of our answers, I can take 1 plus 0.2, which is 1.2, to the T, which is choice C. 18 is the equation A equals 21,000 times 1 minus 0.12 to the T, a model of exponential growth or exponential decay. Growth means we're going up. Decay means we're going down. Think of like tooth decay. If you get a cavity, it means your amount of teeth you have is kind of the teeth surface is going down. And what's the percent of rate per time period? Okay, so right now we're subtracting, so we're decaying. So I'm going to cross out A and B. Now, this number here, the 0.12, is your percentage. That's your percent decrease for the time period. So 12%, if I take 0.12 and convert it over, it's 12%. So choice C. Don't get fooled. I know 1 minus 0.12 is 0.88. That's what's left over. That's not the rate. That's what's left over. What's left over is 88%. What's happening there is that you're decaying at a rate of 12%. Which graph represents a function? Again, vertical line test. I'm going to go through the wrong answers first. If I look at B, if I draw a vertical line, so for example, I'm at 3. My y values are 2 and -2. No good. If I'm at 4 here for an x value, my y value is like 3.2 and -3.2. Not a function. Choice C, same thing. If I draw some vertical lines, I will see that they intersect at least twice, if not 3 times. D, again, vertical line test. I'm intersecting twice. That means there are 2 y values for the same x value. A, however, does not have that property. If I draw vertical lines through A, they only intersect once. A is my function. Number 20, a car depreciates or loses value at a rate of 4.5% annually. Greg purchased a car for $12,500. Which equation can be used to model the value of the car after 5 years? So I'm starting off with 12,500. I'm depreciating or losing value, so whatever's going to happen here, I'm going to have 1 minus my percent as a decimal. So 4.5%. If I make it a decimal, 2 places to the right, it's going to be 0.045. And I'm going 5 years, so I'm raising this to the 5th power. V is 12,500 times 1 minus 0.045 is 0.955. As you see, the choices didn't have it as a subtraction. They actually simplified this, and choice B is the answer. Number 21, the current student population of the Brentwood Student Center is 2,000. The enrollment of the center increases at a rate of 4% per year. To the nearest whole number, how many people are going to be in the Brentwood Student Center in 3 years? So I have my initial amount is 2,000 times 1. I'm increasing enrollment, so plus 4% as a decimal. Move the decimal place back twice. I get 0.04, and we're doing this for 3 years. So basically, I need to plug that into the calculator. And so I can type this directly into the calculator, 2,000, parentheses 1. You want to do plus 0.04, you can just do 1.04 there to the 3rd power. We want this rounded to the nearest whole number. Be very careful. This gives us an answer of 2249.728. which rounds to 2,250, choice B. Number 22, the value of a car purchased for $20,000 decreases at a rate of 12% per year. What is the value of that car after 3 years? So my amount was 20,000 times 1 minus 0.12, and I'm going 3 years. So I'm going to do 20,000 times 1 minus 0.12 raised to the 3rd power. And we're rounding to the nearest cent. If you, if you're looking at the choices, we're going to round to the nearest cent here. We don't want to round it off prematurely, so we get 13629.44 right on the dot. Choice B. Number 23, look at the function that's graphed below. It says, what is the range of this function? And again, I'm going to look for my low y and my high y. I'm just going to create a rectangle. So here's my rectangle, and I want the range of this function. So I'm looking for my low y and my high y. And the way I'm going to do that is I'm going to scroll my rectangle up from bottom to top. So I don't see my graph, don't see my graph, don't see my graph. Boop! There's the first sign of my graph. I have this little point right here. That's my lowest y value, is -3. And I'm going to keep going up, going up, going up, going up, going up, going up, going up. I still see the graph, still see the graph. My peak looks like it's at +3 in my y direction. So my low is -3, my high is +3, and choice B describes that as an interval. Number 24. What is the domain of this function? Again, I'll take my rectangle, and my domain this time is going to go, I'm looking at my x value, so I'm going to scroll from left to right. See the graph right at the onset. If you look, right at the onset, my graph is starting at 0, and I'm looking for my high value. And my high value, the graph stops at 8. So I know my domain is from 0 to 8. Okay? Number 25. Domain and range of a function are shown in the table. Which of the following functions defines g? Well, we can look at this as a sequence. If I look at the y values, they're going up by 4. So I can almost think of this as a sequence. So I want to start off with g of x equals 4n. And notice, this is maybe the tricky part here. I'm starting at 0. If I start at 0, if I think of a graph of this, if I start at 0, my y value is -3. And I'm adding 4 each time. So my graph's going to look something like this, and my y-intercept is going to be -3. So I don't have to go back another 4 here because I'm starting at x equals 0. With a sequence, you start at x equals 1, and you have to go back to find the y-intercept. Number 26, look at this graph of a function, and they want the domain of the function. And again, I'm going to create kind of an index card. Okay, so here's my graph, and I'm looking for the domain. There's the question. Sorry, I covered up the question. We want the domain. And so we're going to move from left to right. I don't see the graph. I don't see the graph. I don't see the graph. I do. Now I start to see the graph. What's my x value? My x value is -4. So that's my low. My low is -4. Then my high, let's see what happens with this graph. The arrow is going on and on and on. There is no high value. So my domain is going to have to start at -4 and just be greater than or equal to that value. So I want to choose choice D. Okay, number 27. What is the domain of this function? I'm going to do this one very quickly. Again, I have my starting point here and my ending point there on my x-axis. This is at -4, be careful, and this is at +4. My domain are my x value, so I don't want to choose choice B because it has a y in it. Number 28, which table represents y as a function of x? I don't want to see repeated x values. And I look at choice A and I see 2 has an output of 2 and 4, not a function. I look at choice B, 4 has an output of -6 and -4, not a function. I look at choice C, 1 input, 1 output, no repeats in my x's, that's a function. D, 3 has 3 outputs, 0, 2, and 3, no good, choice C is your answer. Which relation is a function? Again, we're looking for no repeated x values. So no repeated x values. Same thing in the other question. And if I look, I believe choice B has no repeated x values. Choice A repeats -2. Choice C repeats 4 all 4 times. And choice D repeats 10. So choice B is the answer. 30. The population of the town of Tipton was approximately 30,000 in 1980. We've been decreasing at a rate of 10% per year. Which graph best models this? Well, if I was trying to come up with an equation, it would be A of t equals 30,000 times 1 minus 0.10 to the t. This is an exponential graph. It's not linear. So A is out and D is out. Now, it's a choice between C and B. Exponential decay looks like this. If you wanted to type this into the calculator, you could. You could actually see. Or if you could get values and see what's happening, you could see that choice B will be the answer. Not to mention that if you keep decreasing at 10% per year, the population will never end up at 0, as in graph C. There'll always be some people living there. It's just like in your body, if you have some medicine and that the medicine decays at like 50% per hour, you're still always going to have a little bit in there that's still being processed. 31. Look at the function. We want the maximum value. Maximum is my high y value. The high y value occurs right there, which is at 8. 32, which table values does not represent a function? Again, we're looking for not being a function, we want perhaps a repeated x value. Choice C, 0 gets sent to 0, and 2. All the others have no repeats in the x values. Number 33, which set or sets represent functions? I'm looking at M, 1, 2, 4, 5, no repeated x values, it's a function. N, 4, 2, -1, 3, no repeated x values, it's a function. 3, 4, 3, there's my repeat, 5, not a function. So M and N only, choice B. 34, which represents the graph of y equals absolute value of x plus 2. You can graph this on the calculator. Press y equals. And clear out whatever's in there. And I'm going to type in absolute value of x. How do you get the absolute value? You can go to math, scroll over to num for number, and hit 1 for absolute value of x. Only the absolute value of x is in the brackets. Plus 2, hit my graph key. And there's my graph. Notice it's shifted up 2 units. Okay, it's not hitting the x-axis. It's actually shifted up 2 units. So I'm looking for that graph. And it looks like choice B is it. 35, Bert graphs a function. He says the domain of the function is from -3 is less than or equal to x, which is less than or equal to 2. The range of the function is -1, which is less than or equal to y, which is less than or equal to 6. And the y-intercept is 1. Which graph could represent Bert's function? I'm going to take the y-intercept first. A, because we haven't talked about it in this video, and B, because it's the easiest one to take. My y-intercept, it really should be a 0.01. Well, A has that, so I'll keep A around. B, my y-intercept, where the graph intersects the y-axis, is at -1. Not keeping that. C, same thing. We're at -1 here. D, we're at +1. So now I'm choosing between A and D. Just based on that one piece of information, now you have a 50-50 shot at the question. Now we're going to create our index cards. So here, let's start with the domain for a minute. I want the domain to be from -3 to 2. So I'm going to scroll my index card in the x direction. My graph starts at -1 in the x direction. Not -3, at -1. So that's out. So now I know D's the answer. Let's just verify the information. The domain should be from -3 to 2. Well, I start my x values at, you see this dot here, at -3. And I end up stopping the graph at +2. So I like that. They also said the range should be between -1 to 6. There's my dot. There's my dot. So from -1 to 6, this totally works. 36 says Debbie made the number pattern below. 6, 24, 96, 384, etc. Our idea is what's happening. Well, we have to look. So certainly there's a bigger jump from 24 to 96 than there is from 6 to 24. So we're not adding a certain amount, but we are multiplying. If I do 24 divided by 6, I will get 4. So we're multiplying by 4. If I do 96 divided by 24, I got 4. So, and same thing, 384 divided by 96 is 4. So we're multiplying by 4 each time. So we need to multiply 384 by 4, which is 1536, choice D. 37 asks, which is a geometric sequence? This is a vocabulary word you need to know. Geometric means you multiply to get from one term to the next. And so now we need to look. 15, 25, 35, 45. If you see, we're not multiplying, we're just adding 10 each time. That's an arithmetic sequence. Same thing with B. 15 times 2 is 30, but 30 times 2 isn't 45. So we're actually adding 15 each time, not geometric. 15 times 2 is 30, but 30 times 2 is not 50. This would work if the 50 was a 60, then it would be geometric. So I'm down to D. 15, 225. If I do 225 divided by 15, I'll get 15. If I do 1125 divided by 225, I'll get 15, and so on and so forth. That's my answer. Number 38, use the table below to answer the following questions. If the pattern shown in the table were continued, which number would appear in the box, the column to the left of 14? Well, let's see. I'm adding 4 each time if you take a look. 5 to 9, 9 to 13, plus 14, plus 4, 17. Now, here's the trick, though. I'm skip counting here by 2's. This is tough. So now I have to figure this out. In fact, what I would do is extend the chart. I would literally come down here and extend this. 2, 5, 4, 9, 6, 13, 8, 17. I'm going to 10, 21, 12, 25, 14, 29. Choice D. So you can always rely on your thinking skills to get you through a question like that. Number 39, the pairs of numbers shown below show a linear pattern. It means we're adding a certain number each time. So now here's my pattern. I have 2, it's my sequence, 2, 7, 12, 17, 22, etc. What's happening each time? Well, we're adding 5. So I have, say, A of n equals my 5n. And because I'm starting at 1, I have to go backwards to get to the 0th term, if you will. So 2 minus 5 is -3. And there's choice C. That's the end of the video. Remember, we have review today from 2:45 to 4:45.